Congruent shapes. In geometry, congruence refers to shapes that are exactly the same except for their position. Okay? In other words, one will be a translation, a reflection, or a rotation of the other shape, but the two shapes are identical. Plane shapes are congruent if each shape fits exactly over the other, either directly or by flipping over, rotating, etc. Shapes are congruent if they're identical in shape and size. Now, you would have gone to this link back in year 8. So in this link, you can just show that two shapes are congruent by rotating, reflecting, and translating. Okay, now, there is a symbol for congruent too. So, congruent polygons. The sides or angles that are in matching positions when shapes are superimposed or put on top of each other are called corresponding sides or angles. Instead of writing is congruent to, it's like this symbol, it's like three equal signs. It's like an equal sign with an extra line. Sort of equal and extra equal. That's congruent, okay? So the symbol for congruent or is congruent to is the equal sign with another line above it. Now, we're going to be working in this topic with congruent. In year 8, you looked at congruent shapes just by reflecting, rotating, translating. I think you also looked at the tests for congruence of triangles. In this topic, we're just looking at congruence of triangles. Now, if I tell you that these two triangles below are congruent, it means they're identical. So the corresponding sides and corresponding angles are equal. So side TU is the same as side what? WX, and I want you to go in the same order. TU, WX. Side UV is the same as side XY, and side TV is equal to side WY. Angle TUV, this one up here, equals angle WXY. So we're getting the order correct. I don't want TU equals XW. I need it TU, WX, same direction. UTV is equal to angle XWY, and angle TVU equals angle WYX. So therefore, see, I've got the matching angles up there. This looks like it's a right angle, and I'm going to put a dot in this other corner. So when you do congruence proofs, as soon as you prove an angle's equal, I want you to put markings in there. So if I go TUV, to know that I'm going the right way, I know this is easy because it's the right way up. But I'm going from dot, arc, right angle. Can you see? Dot, arc, right angle. It's congruent to WYZ. You have to preserve the order of the vertices. Okay? Now, if two triangles or polygons are congruent, then corresponding sides will have the same length and corresponding angles will have the same size. Now with these two girls, we can see that one's been, I think, rotated and flipped, actually. I think it's been rotated and flipped. But do you know which angle might be equal to angle B? Let's just see. Which angle E. What about this little angle at A? Which one do you think is its matching one? F. So notice I've put dots at A and F, arcs at B and E, and I'm just going to leave the other one blank. Okay? So angle ABC, that's dot, arc, blank. I have to go in the same order. Dot, arc, blank equals angle FED. Do you see how I've preserved order? Angle BCA is arc, blank, dot. Arc, blank, dot is EDF, angle EDF. And the last one, angle CA, must be CAB. Angle CAB is blank dot arc. Blank dot arc is angle DFE. Do you see? Do you know what I'm doing? I'm going blank. There's no mark on the angle. There's a dot on the angle. There's an arc on the angle. And that's how I preserve my order of vertices. Now, girls, side AB. What does that equal? EF or FE? You tell me. AB, I want the order correct. AB is dot arc. Can you see that? So I want it in the same order. You're going to write EF or FE? Thank you. BC is arc blank. ED or DE? Good. And AC is dot blank. FD. Okay? That is what is called preserving the order of vertices weight. When they say ABC is congruent to FED, let's have a look. ABC dot arc blank, FED dot arc blank. They're the same order as well. I'm going by the markings of the angles. Dot arc blank. Triangles are congruent. They've got 3 equal sides, 3 equal angles. That's 6 pieces of information. Can you see? 1, 2, 3, 4, 5, 6. There's 6 pieces of information when you say that these triangles are congruent. But there are 4 tests that you can use to prove that 2 triangles are congruent, and each test only needs 3 pieces of information. Got it? So, the minimum requirements. These are the tests for congruent triangles, and they're the minimum requirements. So, if I asked you all in this class to draw a triangle with, say, side lengths 5 centimeters, 3 centimeters, and 4 centimeters, you should all come up with exactly the same triangle. So if 3 sides of one triangle, so if I ask you to all draw a 3, 4, 5 triangle, centimeters, no matter who drew it, you should all get exactly the same triangle. I mean, one of you might have the upside down version or the flipped version or the rotated version, but we should be able to cut them out and they will all be congruent, because one of the tests for congruency is that if 3 sides of one triangle are equal to 3 sides of the other, then the 2 triangles are congruent. So we'll mark this by going single dash, double dash, triple dash equals triple dash. Okay? So if you've got 3 sides of one triangle equal to 3 sides of another, the triangles will be congruent. That's test 1. Side, side, side. Test 2 is called SAS. Very important that you put it in that order because the angle is in between. So it's 2 sides and the included angle. Let's say this side I know equals that one. This angle equals that. So where does this other third side have to be if I want 2 sides and the included angle? Is it this side over here or this one here? The first side or the second? So if these 2 triangles are congruent, I've got 2 sides equal and the angle in between them. You know why? Because if I've got 2 sides equal, like the angle in between tells you how far it gets opened up, and automatically the third side has to be the same length for both of the triangles. Okay? But if I've got 2 sides and the included angle here, but 2 sides and another angle over there, not the included angle, you would have more than likely different triangles. All right? So you've got to have, the second test is SAS. 2 sides and the included angle of one triangle are equal to 2 sides and the included angle of another. Now, wait a sec. If you do have those 3 pieces of information identical in 2 triangles, we can now say that the triangles are congruent, meaning that the other sides are the same and the other angles will match up as well. Because remember, when you say 2 triangles are congruent, you can say 6 things about them. 3 sides the same, 3 angles the same, but the tests only require 3 pieces. That's the minimum information you need to say that they're identical in all aspects. Okay? The next one is 2 angles and a side of one triangle are equal to 2 angles and the corresponding side of another triangle. So let's go for this big angle here. We'll go for this one here. Now, it doesn't matter where this third side is. I can put it there, but as long as I put it in the same position for both, I'm going to put it over here. Now, how would you describe, I could have just put one single dash, by the way. See this side? I would describe it as being opposite the arc. Can you see that? So which side is opposite the arc? It's this one. So when you describe sides, I always say this side is opposite the dot, or this side's opposite the arc, or this side's opposite the blank. So two sides and two angles, and any other side, but as long as the side is in the same position for each triangle. Now girls, I could have put the side opposite the arc, or I could have put the sides opposite the dots, or I could have put the sides between the arc and the dot. It would not matter. It's two angles and any other side, but that other side has to be in the same position for both triangles. AAS. Notice it's not ASA, it's AAS. The S can be anywhere. But SAS is very important. The A is in the middle. And the last one is for right angle triangles. So it's right angle for R, hypotenuse is the H, and S is any other side, but of course it has to be the matching side. So we're going to go the longer side or the shorter side of the remaining ones. I don't mind what you do. So we've got, let's go the shorter one. So double dash has to mark this, has to match that one. So in right angle triangles, the hypotenuse and one side of one triangle are equal to the hypotenuse and the other side of the other triangle. Now ladies, this is not SAS. Yes, we've got two sides, but do you notice the angle's not in between? Girls? We've got two sides, but the angle's not in between. This is different to SAS. This is right angle, the hypotenuse, and another side. Girls, you know the Pythagorean triads, right? 3, 4, 5. So if the longer side was 5 and this one is 3, what's the length of that? So if that's 5 and that's 3, that's 4. Automatically, the three sides are the same. See, when you know two sides of your right angle triangle, and one of them's the hypotenuse, you automatically know the third side if you were to use Pythagoras' theorem, meaning that the third sides are the same. Okay? Now, we can click on these links below to explore the first three tests. They're in those links below. Okay? Here's an example. The triangles below are congruent, and you're going to get them in the right order for me. So, girls, what side matches what? 7 matches 7. 10 matches 10. And 11 matches 11. So, girls, I'm going single dash for the shortest, double dash for the medium side, triple dash for the longest side. The triangles are congruent, yes. Name the congruent triangles. I need the vertices in matching order. So I'm going to go triangle PQR is congruent to triangle. I need it in order. And how are you going to tell me the order? I'm going along the single dash side and then along the double dash side. Did you get that? To go along the single dash side and the double dash side, if I go like this and then like that, that's wrong. That's single triple dash. I have to start from here and go along the single dash side, along the double dash side. So the order is what? GFE. Now, there is another way that you could find the matching order, and I do this sometimes as well. See the single dash side and the double dash side? Or I could say, I'm going to put a dot between those two. Or I could say, I'm going to put a dot opposite the triple dash side. So, which is the corresponding angle to Q? Q is opposite the triple dash side. F is opposite the triple dash side. Can you see? Right? Girls, what is opposite the 7? R, or opposite the single dash? What is opposite the single dash? E. Okay? Or we could say the arc that I've just drawn is between the double dash and the triple dash. Or you could say the arc is opposite the single dash. The arc is opposite the single dash. Is cross, it's opposite double dash. Opposite double dash is G. Got it? So P is opposite double dash. G is opposite double dash. So PQR is cross dot arc, cross dot arc. Got it? That's how you preserve order. That's how you know you've put them in the right order without guessing. If you do it any other way, you're really taking a guess. This is definite. Okay, so I have named the congruent triangles and I've given the vertices in matching order. Okay, I'm not going to mark each side. We did that on the sheet before, like I'm not going to name each side. All right, girls, our 4 tests are SSS, SAS, AAS, and RHS. State the test. So we're going to go part A. State the test that could be used. We're just stating tests. We're not doing formal proofs today. I just want to know the test. What's the first one? 3, 5, and 6. What's that test? Oh, sorry, I didn't give the test. Oh, actually, I'm doing the test here. So the test for that one is SSS. B. Okay, girls, 7 is the same. 9 is the same. And the angle in between. What have we got? SAS. Okay? We're just stating the test. We're not doing proofs today. C. Well, be very, very careful. There's 64, there's 64. 52 is there, 52 is there. How would you describe the position of 4? Best to do opposites. 4 is, you would say to me, 4 is where? Girls, describe its position. Opposite what? H. Yeah, opposite what number? 4 is opposite the 52. Is 4 opposite the 52? Yes, they're in the corresponding positions. So I've got, I'll just put a little mark in there for 52. So I've got, which test is this? AAS and D. What have we got? We've got right angle, hypotenuse, and other side. And the test for D is RHS. Okay, while we're here, let's just name them in, stop. A, B, C, single dash, double dash. Which way? Girls, single dash, double dash. Single dash, double dash side. E, F, D. Girls, it is not D, E, F. Do you get that? To get the order, if you're finding that too hard, you could go, single dot is opposite the 5. And I'm going to put a cross opposite the triple dash. And let's get the order now. Girls, ABC is dot cross blank. I need dot cross blank. Dot cross blank is EFD. Got it? That's the other way of doing it. Yes. As long as A's partner is E, B's match is F, and C's match is D, there are 3 ways you could do this. Someone could say triangle CBA is congruent to triangle DFE, and someone could go triangle BAC is congruent to FED, as long as the order is the same. So with B, I'm just going to go PQR because I like alphabetical order for the first one. So for triangle B, I've got PQR along the 7 side and then along the 9. Along the 7 side to the 25 and then along the 9. Give me the order. S-U-T. Not S-T-U, S-U-T. Do you get it? Right. The next one, triangle E-F-G-H. F-G-H. F-G-H is along the side with 4 and then along the side between 64 degrees and 52 degrees. So the order FGH along the side with 4 and along the side with, actually I'm going to put double dashes there because that side is between 64 and 52. That's, all right? I mean, not that it's needed for the proof. All right, so we're going along the side with 4 and then along the 64, 52. What's the order? K, J, L. Get it? And the last one, K, L, M, N. I'm going triangle LMN is congruent to along the side with 5 to the right angle and then along the blank side. What's the order? The order, please. Along the 5 side, along the blank side. What is it? WUV. Now that is preserving order. And you must preserve order. You could now do pages 3 and 4, no, 4 and 5. Pages 4 and 5 on your own. Just finding which triangles are congruent and the test, etc. 1, SSS, AAS, notice the 9 is opposite the 17 degrees, SAS and RHS, right angle, hypotenuse and side. 2, SSS. The next one, it could be AAS, but we need to check the position of the side. The 17 is opposite 61, but here 17 is opposite 53. That is no. The next one is a possible RHS, but let's check. Right angle is correct. Hypotenuse are both 17. The other side's 8. That is yes, RHS. This one could be a possible SAS, but this 12 is in the wrong position. That 12 should be there. Opposite 104 is blank, so this is a no. This is E. It's not RHS, but what is E? 90-degree angle is still an angle. E is what? What is E? It's definitely SAS. Yes, we've got the sides 3 and 5, and included between them is a 90-degree angle. So this is SAS. A lot of people make the mistake, as soon as they see a right angle, they think RHS, but it's not, because you don't have the hypotenuse. But it's definitely 2 sides, and the angle in between them is 90. So that is SAS. Diagrams aren't drawn to scale. I've got 118 and 24, yes, 2 angles. Now let's look at the side. This side is opposite the 118. The 15 is opposite the 118. This is AAS. The reason they've drawn it the way they have is to confuse you. So it's obviously not drawn to scale. What about the next one? 2 sides, and the angle in between's the same. It's SAS. And the last one, 3 sides, is SSS. The last 2 are yes and yes. So is this one and that one. So if I've got the rule, it's a yes. 2 angles. This side is opposite the 13, so is that, so it's yes. This one is yes, SSS. We've got 2 sides in the included, but the 18 is in the wrong position, that's a no. And the last one, we've got right angle, hypotenuse, and other side, that's a yes, RHS. 3. Girls, they are not congruent, or they could be, we don't know. It's not enough information because AAA is not a test. One could just be an enlargement of the other. They are similar triangles. They're not congruent triangles. The only way they would be congruent is if you knew, for example, that this side between 71 and 41 was the same as this side length. And then that would be enough information, because you'd have 2 angles and a side. But AAA is not a test for congruency. And in question 4, you have to choose the congruent triangles in the set. The congruent ones are that and that. They've all got 48 and 77, but the 11 here is between the 48 and the 77. Do you see that? This 11 is in the wrong position. The next one, we're looking at RHS. Which one's wrong? C's wrong because the 25 is in the wrong. So sorry, that's out. Those first 2 are the same. And in the last ones, which one isn't right? A isn't right because the 18 should be over there. We've got, and which rule is it, by the way? This is SAS. What's this one? B. And A? AAS. And the last one, B is incorrect. SSS.